Welcome to this week's session, where we will discuss ChiSquare Test for independence, which means we're going to be using two categorical variables. The previous session, we looked at the relationship when we have two numerical variables. This week, we're going to look at the relationship when we have two categorical nominal or ordinal variables. We are also going to introduce a new table, which is called a chi-square test or critical values of chi. You will find it on your statistical tables. So by the end of the session today, we will cover topics related to chi-square test, but you will learn how and when to use chi-square test for contingency table. If you have a prescribed book, you will notice that the section is too big. The only thing that you need to worry about is only learning about the chi-squared for independence or chi-squared for contingency table. You don't have to learn anything about chi-squared test for goodness of fit test. It's not part of your syllabus. So we're only going to learn about independence. So because we're going to be looking at two categorical variables, in order for us to understand the relationship between them, then we need to put them on a contingency table. And a contingency table is not something new. We've dealt with the types of visualization previously. We also looked at contingency table when we were discussing probabilities. So it should not be something foreign to you, because you used contingency table in the basic probabilities. So contingency tables are useful in a situation where it involves two or multiple variables from the population. So let's say we're looking at two variables. We can look at the relationship by plotting them on a contingency table. And a contingency table is always defined by rows and columns, not the total. Don't count the total. So when we talk about a contingency table, we talk about the number of rows times the number of columns. So you will count, for example, this first table has males and females, is gender. The variable is gender, which has the value 2 rows, male and female. So there are 2 rows. So on this side, it's a row. At the top, it's a column. So 2 rows and 2 columns. And the columns at the top, probably, let's say, it's types of animals you have in your household, a dog or a cat. Or are you an animal lover? Which kind of an animal you like? A dog, are you a dog person or a cat person? Things like that. So there are only 2 columns, 2 rows on this one. So if we look at, maybe here they will say the game night shows that, or game night games that you like to play at night or whatever. You have some sessions. So these are the types of games and the type of food that people prefers to eat and when they're playing these games, and those are at the columns. So on this contingency table, we have the types of games. There are 1, 2, 3, 4. There are 4 rows and 1, 2, 3 columns. So this will be a 4 by 3 column contingency table. And when we look at the last one, where it has low, medium, and high, and yes and no, it has a 3 by 2 columns, and that's a contingency table. You will need to be able to identify that. You will see that I didn't count the totals as the number of rows or number of columns. Other thing that you need to be aware of is sometimes they might give you a contingency table without the totals. In order for you to do the analysis or test for chi-square, you will need to calculate the totals. So if you get a contingency table without the totals, calculate the totals first. So how do we do this relationship? How do we test this? We do this by means of a chi-square test, which is just calculating what a test statistic that is going to help us to look at the relationship between the two values, and we call that a chi-square test statistic. And in your module, like I said, we're only going to concentrate on chi-square test for independence, which uses the contingency table. You will also notice a chi-square test in case they ask you this question in the exam as part of the questions. You need to know that a chi-square test is a two-tailed chi-square test, but we only look at a area of rejection on the upper tail. And you will always notice that when you look at the table, it will also show a graph of a chi-square test where it will have a region of rejection only on the upper tail. But a chi-square test is always a two-tailed test. How do we state the null hypothesis and alternative? How do we test this? Always remember, in your null hypothesis, you're always going to have independence, and in your alternative is going to say dependent. So the statement you will write under your null hypothesis will say the two categorical variables are independent. In your alternative will say the two categorical values are dependent. Or you can say, if we have, let's look at the previous gender and the type of animal. You can say gender and the type of animal are independent in the instance of a null hypothesis. In the alternative, you will say gender and the type of animal are dependent. In your module, only when we talk about the relationship, we can mention things like no relationship or there is a relationship. But for chi-square test, we always talk about independent and dependent. Independent means there is no relationship. One does not have any bearing on the other. Dependent means there is a relationship. One depends on the other one, or one can influence the other one. So we spoke about the contingency table, and I also told you that you need to calculate the total. And a contingency table to calculate the total, we're going, if these are your category and your type of data, let's say our number of rows and number of columns and the values within it, it's A, B, C, and D. In order for us to calculate the total for type A, type 1, we're going to add A plus C, gives us the total. To calculate the total for category 1, it's A plus B gives us that. And that's how you calculate the total, because we are going to use the total to calculate our expected value. From this contingency table, we're going to use the value that you get originally from the table are called observed values. And then we're going to calculate the expected value and calculate the test statistic. So our test statistic is going to be based on the sum of your observed value minus your expected value squared divided by the expected value. In terms of a formula, this is the formula that we're going to be using. The observed minus the sum of your observed minus the expected squared divided by the expected. We're gonna look at the formula later on. How do we then calculate this expected value that I'm talking about? Because you've got the actual values, you need to calculate the expected value. To calculate the expected value, we use this formula. Remember, you need to know how many number of rows you have, how many number of columns you have, right? But you also need to calculate the total. Those are the things. So in order for us to calculate the expected value, we're not going to use the number of rows, we're going to use the totals. So you're going to say a row total times a column totals divide by the grand total. What do I mean by that? Let's assume that we are on this table. If I want to calculate the expected value for A, then the expected value for this observed value A will be the row total, which is A plus B, times the column totals, which will be A plus C column total, divide by A plus B plus C plus D, which is the grand total N. And that is what the expected value will be. And I will calculate for each and every observed value. Once you have calculated your expected value and your observed value, then you're going to calculate your test statistic. And after you have calculated your test statistic, then you're going to make a decision. The rule states that if your chi-square test statistic, which is the complicated formula that we looked at right now, if it is greater than the critical value, which will be the value we're going to find on the table, we reject the null hypothesis. Otherwise, we do not. And how do we find the critical value? We're going to find the critical value by using the level of significance, which is alpha, and the degrees of freedom. And the degrees of freedom for chi-square test, now that's when you're going to introduce those number of rows. If your contingency table is a 2 by 2 contingency table, then you have 2 rows and 2 columns. Your degrees of freedom would be your 2 minus 1 row times your 2 minus 1 column. And that will be 1 times 1, which is equals to 1. And that will be your degrees of freedom. And your critical value, you're going to find it by using that degrees of freedom and your alpha. So you will go to the chi-square test table. You're going to find your alpha at the top, and you're going to find your degrees of freedom on the left. And where your degrees of freedom and your alpha, let's say our alpha was 0.05 is, that will be our critical value. It's still the same as how we have been reading the test statistic, the t-test statistic table, right? So you're going to do the same. You use your degrees of freedom and your level of significance. Because we're doing a test or a hypothesis test, you always need to remember all 4 steps or 5 steps. So I'm going to make it 4 steps. You need to remember all 4 steps of a hypothesis testing, because in your assignment or your exam, all 4 steps can be part of the options, and you need to know how to do a hypothesis testing. Step number 1, you need to know how to state your null hypothesis and your alternative hypothesis. Remember, null hypothesis always has independent, alternative, dependent. Step number 2, you need to define your decision method by finding your critical value. So it means you need to go find your critical value on the critical values of chi-square table. Once you have found your critical value, then you can calculate your test statistic. But before you calculate your test statistic, you need to calculate the expected value. And then after you have your expected value, you're going to take and calculate your chi-squared, which is the sum of your observed value minus your expected squared divided by the expected. We're going to look at how we calculate that. The last step is, after you have calculated your chi-square test and you have your critical value, you need to make a decision. If your test statistic is greater than your critical value, you reject the null hypothesis, and you will conclude by referring back to the statement of your null hypothesis in relation to the level of significance. How do we do that? Let's assume that we sent out a questionnaire where we asked people whether they like, or it's a questionnaire with a lot of questions, but we are interested in 2 questions from that questionnaire. The first question is, do you like TV program? And the answer to that question is in 2 answers, a dichotomous answer, which means they've either like or dislike, and what is your gender? And here we're looking at only males or females. Now, because we've got 2 categorical variables and we want to know if there is a relationship between gender and television program, and we collected the information, we put the information into a contingency table, we need to ask ourselves a question, or we need to test this hypothesis to see if there is a relationship. So the data that we have collected is now in a contingency table. We calculated the total, and we can first start by finding or writing our hypothesis testing, because we are testing. The null hypothesis states there is no relationship between gender and choice. So in terms of your STA 1610 or 1501 or 1510, you will say gender and choice are independent. So your statement will say gender and choice are independent. And your alternative will say gender and choice are dependent. And that's how it will stay. Your null hypothesis and your alternative hypothesis. Now we can go and calculate the expected value. I'm going to do it earlier than at the ChiSquare Test state. So we calculated the row total and the column total and the grand total. We know what those are. We should be able to calculate our expected value. So for every observed value, 36, 14, 30, and 25 are our observed values. In order for us to calculate the expected value for each of these observed values, we're going to use the formula row total times the column total divided by the grand total. So for 36, it will be 50 times 66 divided by 105, and it will give us 31.43. So the expected value will be 31.43. For 14, we say 50 times 39 divided by 105. To open my calculator and calculate that. So for 14, it will be 50 times 39 equals divided by 105 equals 18.57. 18.57. For 30, it will be the row total is 55 times the column total is 66 equals divided by 105, and that will be 34.57. 4.57. For 25, it will be 25 times, 25, it will be 55 times 39, divide that by 105. The 55 times 39 equals, divide by 105, gives me 20.43. And those are my expected values. So I calculated the expected values, and I need to go and find the critical value. That's the next step, right? So to find the critical value, I need to use the degrees of freedom, and the alpha. If our alpha was at 0.05, our degrees of freedom is number of rows times number of columns. There are 2 rows, 2 columns, so the degrees of freedom is 1. To calculate the chi-square test, our observed, I just rewrote this in this manner. I just transpose it. You don't have to, but I just transposed it. And I started first by calculating what is in the bracket at the top. 36 minus 31.43 gives me 4.57. Square and I do for all of them. But in order for me to get 0.65, I take this 4.57, square that answer, divide by 31.43, which gives me 0.67. And I do the same, square this answer, square this, divide by that number, 18.53, and you get 1.12. When you square negative 4.57, divide it by 34.57, you get 0.3. When you square 4.57, divide by 20.43, you will get 1.03. And you add all of this value because it says the sum of the observed minus the expected squared divided by the expected, we get the answer of 3.42. Now we can go and find our critical value. I did my steps haphazardly. I didn't follow my 4-step the way I outlined them. So now we're going to find the critical value. Remember, we found the degrees of freedom to be 1. We went to the test chi-square, critical values of chi. If you have your table in front of you, you can open that as well. You look for the degrees of freedom of 1, and you look for alpha of 0.05, and we find the degrees of freedom to be, or the critical value to be 3.841. So we calculated our test statistics to be 3.42. We found our critical value on the table, and it is 3.481. Where is my 3.42 falls? It falls in the do not reject area because it is less. And we do not reject the null hypothesis. Just give me a second. I need to find my laptop charger. Okay, so back. We do not reject the null hypothesis, and therefore we can conclude by saying that there is no significant relationship between the choice and gender at alpha of 0.05. And that's how you do your test, your chi-square test. Let's look at another example. According to the Center of Disease Control and Prevention publication, HIV and AIDS Surveillance Report, the number of AIDS cases in South Africa in 2007, classified by gender and race, use the info shown below in the following contingency table to test whether there is a relationship between gender and race. Now, looking at this table, you might even say, what's happening here? The table is not complete. What am I supposed to do? Easy. We told you how to complete the contingency table. If I have a total and I have my males, I can calculate what my females are because especially for the white row, because 40 plus the number of females, the 40 males plus the number of females will give me 70. So in order for me to get the females, I'll just say 70 minus 40. On this other one, I just need to calculate the total. You just add all of them to create your total. On this one as well is the total. Here there is missing information, but when you start completing the missing information, it will start complete. Your table will start including all the other values. So let's see how we can do this. This is our 3 by, it's a 3 rows, 1, 2, 3 row, and 2 columns. So it is a 3 by 2 contingency table. So we're going to say 70 minus 40 is 30. We're going to add the 2 values, we get us 70. And 250, it will be 250 minus 70, 80 would give us 100. And then we move to 100 minus 48 gives us 42, 52. And we just add the remaining columns. And our contingency table is complete. State our null hypothesis and alternative hypothesis. Race and gender are independent. Alternative, race and gender are dependent. Let's calculate the expected values. For 40, 70 times 120 divided by 250 gives us 33.6. For 30, 70 times 130 gives us 36. And we continue to calculate all of the expected values. Once we have calculated our expected value, then we can calculate our test statistic. 40 minus 33.6 squared divided by 33.6. 30 minus 30, or plus 30 minus 36.4 squared divided by 36.4 plus 32 minus 38.4 squared divide by 38 until we get to 52 minus 52 squared divided by 52. And when we calculate all of this and sum them up, we get 4,3956. We're going to find the critical value by using the degrees of freedom. So let's find the degrees of freedom because I didn't calculate the degrees of freedom on here. So our degrees of freedom, we'll get it by using the number of rows minus 1 times the number of columns, or number of columns minus 1. So we have how many number of rows? We have 3 rows minus 1 times we have 2 columns minus 1. So the answer here will be equals to 3 minus 1 is 2, 2 minus 1 is 1, 1 times 2 is 2. Our degrees of freedom is 2. Our alpha is 0.05. They would have given you in a statement when you are writing your assignment or questions. So at alpha, so we've got our alpha of 0.05. We need to go to the table and find that. So you go to the critical values of chi table. You look for the degrees of freedom of 2, and you look for 0.05 alpha, where they both meet. That will be 5,991. Once you have your critical value, then you can make your decision. You know, the rule says if the test statistic is greater, we're going to reject the null hypothesis. So we know what the test statistic is. We calculated it. It is 4. Sorry, delete this, erase. Our test statistic is 4,3956. Our critical value is 5,999. Where does it fall? Our critical value and test statistics. So our test statistic is less than our critical value, therefore we do not reject. So it means if we throw this will have been 5,991, and our 4,3 would fall in the do not reject area, because this is the rejection area. And we can then conclude that there is no sufficient evidence that race and gender are related. And that is it. Are there any questions? If there are no questions, let me check the chat. Nothing on the chat. Nothing. Nada. So let's look at more examples or exercises to help us with this. Okay, so the certain media company published a 4 magazine for teenage market. The executive of the company would like to know whether readership preference for the 4 magazines is independent of gender. A survey among 200 teenagers were carried out. The following contingency table was obtained. We've got gender, girls and boys, and the magazine preference, beat, youth, grow, and life. Which one of the following statement is incorrect? And the first question says, the expected value for youth and girls is 14.82. So what are they expecting you to do? Is to go and calculate youth and girls. The expected value for 12. If I look at my table, it's missing certain information. The total, which are very important. So before I can do anything to youth and girls, I'm going to calculate the total for them. I'm not going to calculate the total for all of them. I'm only going to calculate as I go along because of time. So 2 plus 6 is 8, and 3, therefore it's 38. And I know that the grand total is 200 because they told me that they interviewed 200. So girls, 18 plus 12, this one needs a calculator. It's 80. Plus 20, it's 50. Plus 28 is 78. So to calculate the expected value for youth and girls, it will be 78 times 38 divide by 200. Do we get the same answer? Okay. 78 times 38 divided by 200. It's 14.82. So that is correct. That's how you will answer the question. The null hypothesis. Remember, null hypothesis, always independent. So let's see if that statement has independent. The null hypothesis is gender and magazine preference are independent. So therefore, it means that statement is true. The alternative hypothesis will state that it is independent. That statement is correct. Number 4, the degrees of freedom is 3. So how many number of rows we have? We have a contingency table with 3 rows and 1, 2, 3, 4 columns. So it's number of rows minus 1 times number of columns minus 1. We've got 3 rows minus 1 and 4 columns minus 1. And therefore, it will be 3 minus 1 is 2 times 4 minus 1 is 3. The answer would be 2 times 3 is 6. And therefore, our answer that we are looking for is I think on this question, the two things, this should have been unsymmetrical because a chi-square curve is not symmetrical. It's left skewed.
Sorry, Lizzie.
Yes.
I wasn't here for the last, I think, 5 minutes. I've got issues with my network. You got four columns.
Yes, it's beat, youth, grow, and life.
And the rows?
Boys and girls.
But you got 3 minus 1.
Oh. Yes, sorry. You are right. My. So this is 2. Sorry, I don't know where I got 3. Thank you for being awake in the morning. So it's 2. That it means it's 1. That it means it's 3. That it means is the answer is 3. That it means number 4 is correct. Sorry, my bad. And a chi-square test, it is not symmetrical. It is non-symmetrical because remember, we said it is left skewed. You must also look at the graph on the chi-square test table. Okay. Moving on to the next question. Which one of the following statement is incorrect about chi-square test of independence between 2 variables? This type of questions is just to test your knowledge, right? They don't expect you to do any calculation. They want to know if you understand the content. Number 1, the test statistic has number of row minus 1 times number of columns minus 1 degrees of freedom, where R is the number of row and C is the number of columns. Is that statement correct or incorrect? It is correct because R is number of rows, C is number of columns. Number 2, the observed frequency for each cell is equal to the row total times the column totals divided by n, where n is the sample size. Is that true? No, it's not, because the observed value is the value you are given in the contingency table. The expected frequency for each cell equals the row total times the column total divided by the grand total, or your sample size. So 2 is incorrect. The 2 variables are qualitative. Yes, they are qualitative because we're working with categorical variables. That statement is correct. The null hypothesis is that two variables are independent. Yes, we always know that for a null hypothesis, the statement always has to be independent. If the observed and the expected frequency for each cell are equal, then the test statistic will be equals to 0. What does that mean? So let's assume that we have a contingency table with column 1 and column 2 and row 1 and row 2. To make it smaller. Okay. So let's assume that this is 1, 2, 3, and 4 observed value, and our frequencies are 1, 2, our expected frequency when we calculate them, they are the same. Remember? So the numbers at the corner are our expected frequency. So if we have to calculate our chi-square test statistic, what this statement say is, we know that it is your sum of your observed minus your expected squared divided by your expected. So what does that mean? It means 1 minus 1 squared divided by 1 plus 2 minus 2 squared divided by 2 plus 3 minus 3 squared divided by 3 plus 4 minus 4 squared divided by 4. 1 minus 1 is 0. Any number, regardless whether we are squaring it or doing anything, will be equals to 0. 2 minus 2 will be 0. 3 minus 3 will be 0. 4 minus 4 will be 0. So therefore, the answer here will be equals to 0. And that's what the statement is saying. If your expected value or your expected frequency and your observed frequency are equal, then the test statistic will be equal for all cells. So these are the cells. If they are all equal, like, oh, sorry, on this last one, I made it for something is wrong with my mind today. So if all of the observed and the expected are equal, then your test statistic will be equals to 0. Okay, so that's what that statement is saying. Looking at another way of asking questions, they might ask you, consider a contingency table which has 4 by 4, which means 4 rows and 4 columns. You are required to test the independence of rows and columns variable at 1% level of significance. Which one of the following statement is incorrect? Number A, it says the critical value will be denoted by that. So how do we write the critical value? Yes, we're going to find the critical value by using alpha and the degrees of freedom. And we know our degrees of freedom is number of rows minus 1 times number of columns minus 1. We have a 4 by 4. So it will be 4 minus 1 is 3 times 4 minus 1 is 3. So it will be 3 times 3 is 9. We also know that we have our alpha of, this is our alpha, which is 0,01. So therefore, our chi-squared will be 0,01 and the degrees of freedom of 9. Is that the same? It is the same. The null hypothesis is that the two variables are independent. I'm going to ask you, is that correct? This time around, I need your answer. Is that statement correct? No. So you're deciding not to talk to me? It's fine. That statement is correct. We've been saying it. Null hypothesis, H naught, always state independent. Number C, it says the critical value is 21.66. So you need to go to the table, look for alpha of 0.01 on the table and the degrees of freedom of 9, where they both meet. That answer should be either that. If not, then that is incorrect. So you need to go to your critical values of chi. Maybe let me sharing and share my entire screen and go to the chi's critical values of chi. This is the table I'm referring to. And we're looking for alpha of 0. Remember also, you don't have to worry about those values at the cumulative probability. We're working with the values on the under the upper tail, values closer to the table. So the column we're looking for is 0.01, and the degrees of freedom is 9, and where they both meet, and you can see that that is 21.66, which is exactly the same. So that is correct. And this one says the degrees of freedom is 16. We found that the degrees of freedom is actually 9. So that was the incorrect one. And this is the same as what we have dealt with previously, right? In the last question. I'm not going to repeat that. So it is the same question as that one. So you can see that they like asking it either in the exam or in your assignment. These are the questions I get from your past exams or past assignment questions. Okay, so last one before we call it the quits for the last time. Consider the following contingency table of observed values. So they give you the observed value. Calculate the chi-square test statistics required to test the independence of the number of columns and rows, and choose the correct answer from the list of options below. Therefore, it means the first thing that we need to do is to go and calculate the expected value for every one of them. But before we do that, we need to calculate the total. If you go onto my YouTube channel and look for a chi-square test for independence, for the previous sessions that we did previous years, there is another way of doing these questions using the Excel template. We do have an Excel template. I will share it on WhatsApp as well. You can access that and use that to answer some of this because it simplifies your life. So total, this is 84. This will be 100
and 129.
and 129. And 110 plus 88 is 198. 34. Oh, this one needs a calculator. I cannot calculate it by with my. It's
150.
150. And the total?
348. 348.
348. So now let's calculate the expected values. For 50, it will be 198 times 84 divided by 348.
Uh, 47.79.
Okay. What I'm gonna do, I will just I'm not gonna write them there, so I'm gonna just continue and write the formula. Observed minus expected squared divide by expected, and then substitute the values. So we have 50 minus, I'm only gonna keep 4 decimals so that
Okay.
we get the answer correct. 47.
79931.
And you need to do all of them. I'm lazy. Until you get to 41 minus 40. So 150 times 129. So you'll have to calculate for the entire table. Oh, divide by 348, which is 55. So you'll have to calculate the expected value for all of them. And once you are done, then add them together. I'm just gonna go back, stop sharing, open, because I also want to show you, since we are almost running out of time. State of wasting time to calculating manually. Just give me some time to locate the templates. Wait. If I can find the templates, then I can show you how to use the template. But now I'm struggling to locate the templates. Oh, I found it. Found it. I have to share my entire screen as well. Okay, so this is the template that I'm referring to. So we're gonna need to get to my taskbar to minimize this. Sorry, just give me a second. Things are not working the way I want them to work here now. Oh. Okay. So you need to recognize what table it is. It is a 2 by 3 contingency. So I've got different contingency tables here. So you will see that they've got a 3x3, 2x3, a 2x2, and a 3x2. So since our one is a 2x3, I'm gonna just hide the rest of the other things so that then able to see that. So we're gonna use this. So the only thing that you need to change, you can change the wordings at the top. So, and use the same A, B, and C. And this one is P and Q. And you just need to delete all the numbers that are written in the white columns or in the white rows and ignore everything else that is happening on the sheet. We're gonna get to that. So we're going to replace all that with 50, 60, and you will see when you do that, automatically the gray part gets calculated and the other values at the bottom also gets to be calculated. So just worry about including all these other values. 75 and 41. And here are our expected values calculated already. You can see 55,6345, which is the same as what we calculated. Then we can also check the other one that we calculated, which was 47.7931. You can see the this. Okay. So once we have calculated our contingents, once we have calculated the expected value, so this will calculate your expected value automatically in order for me to increase the decimals on this one. You just use the number another to increase it. And this bottom part where I've got values here, I am calculating the formula observed minus expected squared divided by the expected is just taking the observed, which is 50, minus 47.7931, square the answer and divide by 47, and that will give you 0, that. And then once I'm done with calculating all of them, all I do is add all these values. So you will see that this is just the sum of all these values. And the sum of all those values is our test statistic. So let's go back to our question and look at our test statistic. They said our test statistic is how much? Okay. It's 15.51. And that is option number 3. You can use this. I will share with you on WhatsApp as well, the template. And you can use it. And because this is the last time I'm seeing you, I have to do this. Thank you for always being part of the session and for attending my sessions, the free sessions that we offered. And I think this was my other way of saying goodbye to everyone and not leaving you in a limbo, since I'm no longer continuing with tutorials, right? So I'm doing this privately. I do this through my company called Pambili Analytics, where I'm trying to also bridge the gap in terms of data literacy and analytical skills. Not only do I offer only the tutorials on statistics and all that, we do much more than just statistics. We do data analytics and business consulting in terms of literacy programs as well. But also we do assist with research. If you know someone doing honors or PhD or masters and they're looking for someone to help them with the research part of their modules, something like that, we can always also assist. But more specifically, if you know any company that is doing market research and they are looking for people to assist with research or data literacy, we are also available to do that with other companies. But our flagship has always been on assisting with skills development, where we do face-to-face or online skills transfer of knowledge. And we no longer have this on special. I should have fixed the slides. We also do have our self-led online learning sessions on data literacy, data analysis, and data and research design and methodology. And you can do the program for 3 months. It will equip you for your work environment as well. We would also like to appreciate all the people who subscribe to our YouTube channel. Please remember to continue. If you haven't subscribed yet, please go to our YouTube channel and subscribe. Press the notification button to receive any videos or notification when new content is added. We also have videos, especially like for these sessions, where you can only access some of these videos if you become a member, not just subscribing, but becoming a member. We've got different types. We've got 5 levels of membership, but the most important ones are the loyalist, appreciator, and promoters. If you join our channel as a member, please make sure that you select the correct membership channel in order for you to receive the benefits for each membership level as well. And we would like to always say thank you to our loyalist members. I'm yet to see our appreciators and promoters, but we always appreciate our loyalists. But we also do have our cheerleaders and supporters. We also see you and recognize you, and thank you for the contribution that you always do or make in order to support our channel. Thank you very much. And if you want to get hold of me, you can use the email address, or you can find me on WhatsApp. Otherwise, you can visit our website and our YouTube channel to gain free lessons from there, from our YouTube videos. Thank you and have a blessed weekend. And good luck with your studies. But always remember, we are available if you need any assistance. Thank you and goodbye.
Thanks, Lizzie.